Hello guys, welcome back. This is the 11th video where we discuss the previous year questions in network theory. And in this video, we'll see another question from GATE EC 2021. So the switch in the circuit in the figure is in position P for a long time and then move to position Q at time t equal to 0. So from here, the switch is flicked to this position. The value of dV of t by dt. So what is V of t? V of t is nothing but your voltage across your capacitor. So they're asking for the value of dV of t by dt at t equal to 0 plus, and they are given 4 options. So we already came across similar questions in GATE 2022 and 2023. So if you see the pattern, you can observe that these type of questions are repeating every year. So it is good to know how to solve these type of questions. And it is fairly straightforward and simple. So we already discussed that we want to know two concepts. So one is that your voltage across the capacitor cannot change instantaneously. So capacitor voltage can't change instantaneously. Similarly, your inductor current cannot change. So inductor current can't change instantaneously. So again, why is this the case? If you go back to your basics, for a capacitor voltage to change instantaneously, your current should be infinite. Similarly, for the inductor current to change instantaneously, your inductor voltage should be infinite. So whenever there is a resistor in series or parallel with your capacitor or inductor, the voltage change or the voltage drop, extra voltage drop will be taken by the resistor. Similarly, for the inductor case, the extra current will be taken by the resistor such that the inductor current itself doesn't change instantaneously. But in some cases, if the voltage for the inductor itself is an impulse meaning it has a infinite voltage, let's say at one point, so then your current can change instantaneously. So your current will be a step. Similarly, for your capacitor, if your current is an impulse, your voltage will be a step. So you need to always remember the basics. Just don't take these words as it is. Okay, so now let us try to find the voltage and current at t equal to 0 minus. So what does this mean in terms of equations? Vc of 0 minus is equal to Vc of 0 plus, and IL of 0 minus is equal to IL of 0 plus. So let us find Vc of 0 minus and IL of 0 minus. So in 0 minus, how is the switch? The switch is this way, right? It is connected to P. So we can remove this part. So now if you see what is there, this is nothing but it is connected for a long time. So your caps will be open, your inductors will be short. So what do you have? You have 20 kilo ohm, 5 kilo ohm, another 5 kilo ohm, and your capacitor is open and your inductor is short. Here you have 10 kilo ohm. Okay, so now if you see, this is effectively like 20k. This is 20 volt. This is 20k. And this is 5 plus 5 plus 10, another 20k. So can we try to find Vc of 0 minus and IL of 0 minus? So first let us find IL of 0 minus. So IL of 0 minus is nothing but the current in this arm, which is nothing but 20 volt by 20 kilo ohm, which is 1 milliamp. Okay, so 1 milliamp is flowing in this arm. So if I take this as ground, so what will be Vc of 0 minus? So it will be 1 milliamp into 10 kilo ohm. So it is equal to 10 volts, right? Okay, so now let us go for 0 plus case, t equal to 0 plus. So let us do it for the case of t equal to 0 plus. So a switch is actually connected in this position. So this part of the circuit is not required, right? This is not required. Only this part we are dealing with. So how will you write this? You have 5 kilo ohm. You have plus minus V of t. And you have a resistor and an inductor. 0.1 millihenry, 10 kilo ohm. And this 1 millifarad. So now we know Vc of 0 plus is same as Vc of 0 minus. So the voltage across this cap should be 10 volt at t equal to 0 plus. And similarly, current in this arm cannot change because the inductor will hold that current. So this current should be 1 milliamp. So if this is 10 volt, what should be the current in this arm? It should be 10 by 5. 10 by 5k, which is 2 milliamp. So what is the current flowing across your cap? So current going out of your cap is IC is nothing but 2 milliamp plus 1 milliamp. So IC of 0 plus is 3 milliamp. What they have asked to find? We have to find dV of t by dt. So V of t is nothing but your Vc of t itself, right? So what will be v of t dv of t by dt? If you remember, for the capacitor, your current IC is equal to C into dv vc of t by dt, right? So this is your IC of t. So your IC of 0 plus is equal to C d vc of 0 plus by dt, or you can say this value at t equal to 0 plus. So that is what they are asking us to find. So if we just take the C this side, your dvc by dt at t equal to 0 plus is IC of 0 plus by C. So what is IC of 0 plus? 3 milliamp. And what is your C value? It is 1 millifarad. So your answer is 3 volt. But if you notice, what is happening to your capacitor? Is it charging or discharging? So if you notice, it is discharging. So your value should be minus 3. I mean, the sign should be negative. When we write this equation, it is the current flowing into the capacitor. And Vc is your change in the capacitor voltage. So here itself, you will get a minus sign when you substitute this as V of t. So finally, you are getting minus 3 volt per second because it is dV by dt. So your answer is option C, minus 3 volt per second.